Okay, hello everyone. Let me just start a video just quickly so everybody can see how I look. Just a quick sharing the video. There you go. Okay, let me introduce myself. My name is Sandy Winarko. I'm the principal PM in Azure Data Governance at Microsoft. My team works and develop the data integration products that include the Azure Data Factory or ADF and SQL Server Integration Services or SSIS, also including the Master Data Services or MDS and Data Quality Services or DQS. So in the following, when I present the deck, I think I'm going to stop the video just so to make sure that I can minimize the bandwidth because I'm calling from China, then I want to avoid a network or latency issue, okay? Let me stop it. And I'm going to do the slideshow. You can see my slide, right, Jarek?
Yes.
Oh, great.
Clear.
Okay, for this session, I will cover everything you need to know in order to accelerate the cloud migration of our legacy SSIS packages using Azure Data Factory. We'll go over most recently released features that unblock and accelerate this migration. We'll go through the agenda first. Quickly, I will talk about the learning objectives and takeaways that you can have from this session. And then I'll do a quick flash introduction of SSIS separately from ADF, and then the reason why we integrate SSIS inside ADF. And then we move quickly into a best practice recommendation to migrate SQL Server estate from on-premises to the cloud, using an all-platform as a service or all-PaaS solution of SSIS in ADF and Azure SQL Managed Instance. And then I'll take you back down the memory lane to learn about the evolution of SSIS from on-premises to the cloud and all the design decision we make when we actually create a SSIS platform as a service in the cloud. And then I will dig deeper into the features to ensure a secure data access from SSIS PaaS in the cloud. When it can still access data on premises or in different clouds. And finally, I will also talk about the extensibility feature for SSIS PaaS. We will introduce the new third-party licensing method where you can build your own custom or ISV components, and then you can integrate with the SSIS running in the cloud. And then I will close the session with a migration SSIS migration playbook that will show you all different permutation and scenario when you migrate different version of SSIS and different storage type of your packages to the cloud using Azure SQL Managed Instance or Azure SQL Database as the migration destination. And then let's see how much time we have left to do a few demos. I have a lot of demos, but I think we can only do probably one or two. Okay, let's start with the learning objectives. So far, we don't have any question about the agenda. Is there anything missing that you guys want to cover? Jarek, it's okay? No questions so far, right?
No questions now.
Great. Okay. So on the learning objective, there are three parts. Essentially, I will repeat the mantra throughout the session. The first thing that you will learn is to rehost or lift and shift your existing ETL workloads. And the manner you do this is we want to actually allow you to do it with minimal or no changes. So essentially, the same packages that run on premises can be run on the cloud without any changes or redesign. All you need to do is probably do a runtime property value assignment. And you can do that through SSIS parameters, connection manager property, or property overrides. And you build the infrastructure, a full PaaS solution that actually combine two different PaaS solutions. One is Azure SQL Managed Instance, and the other one is SSIS in ADF. So when you rehost SSIS in the cloud, we actually separate or decouple the database engine from the ETL engine. Once you prepare the all-PaaS solution in the cloud, then you will learn how to assess the packages your packages for cloud compatibility and test these packages to run in the cloud using SSDT, for example. And then once you know that your packages can run in the cloud, you will learn also to redeploy and migrate them, all your packages and job to the all PaaS solution. And finally, once the packages and jobs is already migrated, you can operationalize it using Azure Data Factory as an orchestrator, using Azure Monitor for the operation of your ETL workflow, and also Azure DevOps to implement CI/CD across your development, testing, and production environment. So after all that, you can actually start learning how to enhance your ETL workflows and opening the door for big data or modern data warehouse. Because with the SSIS in ADF, you can actually run your SSIS package as a first-class SSIS activities inside ADF pipeline. And because it is actually running inside ADF pipelines, you can combine SSIS activities with other native ADF activities, and this will make you creative and help you basically enhance your ETL workflow with many different connectors, connectivities, transformation, etc. And finally, you will also learn how to extend your ETL workflows with custom open source and third-party components. So if you don't find any of the built-in or pre-installed component from SSIS and ADF meet your purpose, you can actually build your own, or you can purchase from our ISV partners, and you can extend your ETL workflow in the cloud. Okay, so you can fill functionality gaps and innovate in data integration. So always remember this mantra: rehost, enhance, and extend. Okay. So far, I hope I didn't go too fast. If there's any questions so far, Jarek?
Still no. I will interrupt you if someone asks.
Oh, you will, right? Okay, good.
Yeah.
All right. Okay, let's do a quick introduction of SSIS first, and ADF, and then also SSIS in ADF. Let's start with SSIS. SSIS, as you all know already, is a traditional ETL tool targeting customers who manage their SQL Server on premises or on a VM. This has been around for like almost more than 20 years, right? So in analogy, running a traditional ETL workload on premises is like being on the ground floor. ADF is basically recent development from Microsoft. This is a new data integration platform that we built native in the cloud. It is actually targeting ELT pattern, which is extract, load, and transform. If you can see on the diagram on the left-hand side, you can see that you can extract data from various sources, ingest it into a data lake where you can have a structured and unstructured data, and then you can transform and basically operate on that data using a big data compute like HD Insight, Databricks, or Apache Spark. And then you can ingest or load that into Azure Synapse Analytics and then present it using Power BI, right? So as an analogy, you can imagine running a modern data warehouse pattern or ELT pattern in the cloud. It's like being on the 7th floor. So essentially, knowing that SSIS has been around for a long time, moving all these SSIS packages, hundreds and thousands of SSIS packages, and converting it into ADF native activities, it's almost like jumping 7 stories straight up, which is virtually impossible. So how do we bridge between SSIS on the ground floor with ADF in the 7th floor? So enter SSIS in ADF, which is essentially an ETL platform as a service integrated inside ADF. So it's using an ADF native compute engine that's dedicated to execute SSIS packages. And this is actually aimed so you can rehost your SSIS packages with minimal or no change and running in ADF. So as an analogy, it's like an escalator. So with SSIS in ADF, you can convert slowly at your own pace part of your ETL workflow where you want to replace with the native ADF activities, or leave it the same way in its original packages running inside ADF in a fully managed infrastructure. So the reason why we do this is like because SSIS on premises will always be bundled with SQL Server. So there's always a SQL SSIS on premises workload. And when customer wants to migrate this SSIS workload from on-premises to the cloud, SSIS in ADF is the path of least resistant and the easiest way to run in the cloud with no or minimal friction. And then once you run it in the cloud, you can modernize it using ADF. Okay. Okay. So far, you have not interrupted me, right? So there's no question. All right. So let's go to the next chapter. We'll talk about the best practice recommendation, how to migrate your SQL Server estate from on-premises to the cloud. In this case, we can start with on your on-premises estate, right? SQL Server will have like a primary value-added services. Mostly the three major value-added services is SSIS integration services, SSAS analysis services, and SSRS reporting services. When you decide to retire your SQL Server or at least migrate some of them to the cloud, the first thing that you need to consider is if there is any full compatible PaaS solution. And this actually provided for the SQL Server for the database engine and for the ETL engine. The database engine can be migrated or rehosted with full compatibility into Azure SQL Managed Instance or MI, while the ETL engine can be rehosted into or can be replaced with SSIS in Azure Data Factory. The other value-added services, which is AS, for example, analysis services, can only partially rehosted in the cloud because the PaaS solution for analysis services, which is what we call Azure Analysis Services or AAS, currently only support tabular model. So if you still have a multi-dimensional model, you have to leave it on premises or maybe running it on Azure VM on an SSAS, right? And if you have like a reports that produced by your reporting services on premises, there is no PaaS solution for SSRS, but you can actually replace or at least upload the reports into a new software as a service solution in the cloud, which is Power BI, and that's actually the solution that we recommend for basically replacing SSRS with the solution in the cloud. Once you run your ETL in the cloud with SSIS in ADF, you can see that you can actually connect to all different resources, either on premises or in the cloud, because SSIS come with like a SSAS component, so you can actually refresh your multi-dimensional model on premises, or it also come with AAS components where you can use to refresh your tabular model in the cloud. It also has recently we released a new component which is called a Power Query Source. So it can actually operationalize or execute PQ scripts that produced by online Power BI Online or Excel, for example. SSIS in ADF can also fetch packages from SSIS DB or SSIS catalog hosted by Managed Instance, or even the legacy SQL Server database or MSDB that also can be hosted by Managed Instance in the cloud. While SSIS in ADF is in the cloud, it can also still access all data stores on premises like file system and SQL Server itself. Let me see. Once you run SSIS in ADF, you can, like I mentioned before, you can start enhancing it. ADF come with like 90 plus connectors. So if you don't find any connectors from the built-in SSIS component, you can actually combine it with the ADF native connectivities and combine it in a single ADF pipeline with SSIS activity, for example. And even if you don't find the built-in ADF connectors or SSIS connector fit your purpose, you can extend it with your own custom connector components or from our ISV partners. In this case, you can see we have all our partners already adapted their components to run on SSIS IR. For example, Theobald Software provide all these SAP connectors, connectivity, right? And Varigens, Zapisis, Cozirock, SentryOne, etc. One thing that I like to highlight also, for example, one of our partner in Germany, their name is OH22 Information Services. They actually built a cloud alternative as a replacement for data quality services. You can find these components in Azure Marketplace, and this component can be integrated with SSIS in ADF. So you can actually operate data cleansing or data matching operations in the cloud, everything running in the cloud, orchestrated by SSIS in ADF.
Excuse me.
Sure.
We have one question from Alexander.
Okay.
He's asking, is there any plan in place to create PaaS component which would replace MDS?
That's a very good question. We do have a plan, although we don't have a fixed ETA yet. If you look at if you actually have an NDA in place, we do actually share the Azure Data Factory and Azure Data Governance roadmap with our MVPs that has an NDA. We do actually have a long-term plan to build a master data management services, but at this point we don't have the exact ETA yet for that. For now, we recommend to use a partner, for example, Proxy MDM solution, or even Informatica is pretty good for now. While for DQS, we already have an alternative for a replacement that I mentioned before from OH22 Information Services. Okay. Any other question?
No, that's it for now.
Okay. All right. Let's move to the, let's take a stroll down the memory lane, and let's go through the evolution of SSIS from on-premises to the cloud. Like I mentioned before, SSIS has been around for a long time, even before the year 2000, I think. It was born with the name DTS, I think Data Transformation Services. It was rechristened or renamed SSIS in 2005. It was always supporting the original deployment model was called package deployment model, where you actually deploy your packages into a file system or MSDB. And in 2012, we introduced SSIS catalog or SSIS DB, so you can actually deploy your packages into for example, SQL Server SSIS DB database, where you can have a better interface and better logging solution, etc. The big year for us is actually 2017, because in that year, in 2017, we introduced 3 features. The first one is actually we show that SSIS can be operated on Linux, can run on a Linux. There's a SSIS command line based runtime that can be run on Linux. And secondly, we introduced a scale-out feature where you can run SSIS on a master worker, a single master, multiple worker topology, so you can run many packages in parallel. This scale-out feature actually formed the base for our SSIS platform as a service inside ADF. So SSIS in ADF is essentially a scale-out SSIS fully managed as a PaaS. Okay. Other than that, basically all the tools are familiar with you, like SSDT and SSMS, all the command prompt utilities, dtutil and dtexec, all of those we carry through when we introduce the PaaS solution, such that all these tools can be used, all the traditional tools can be used to operate SSIS on-prem as well as in the cloud. In terms of pricing, you know, like a SSIS bundled with SQL Server is free, so there's no pricing. And when we actually lift and shift it to the cloud, the first thing we do is like we want to make sure that we support both models, the project and package deployment models, because from our telemetry we saw that even though the project deployment model, where you deploy your packages and project into SSIS DB, is the most recent and the most modern one, about 60% of our SSIS on-premises are still running package deployment model. So that's why now SSIS in ADF support both models. So you can deploy your package anywhere you want, the same way like you do on-premises. Okay. And in fact, for example, file system, you can still deploy your package into file system or into Azure File Share or Azure Files, etc. When we lift and shift SSIS into the cloud, we actually separate the storage from compute. We make sure that like actually the compute is running in ADF, and this compute in ADF, we call it Azure-SSIS Integration Runtime or SSIS IR. And we make sure also, like I mentioned before, we Azure enable all the traditional tool, so we can preserve your skill set, and essentially you can use all the same tools on premises and also in the cloud. So you can connect to your SSIS DB catalog in the cloud using SSDT or SSMS. You can test your packages from SSDT. You can even, for example, orchestrate your package using a third-party orchestrator, like let's say Control M or Active Batch, by invoking an Azure-enabled dtexec, for example. And Azure SQL MI agent, for example, is also an orchestrator that comes with Azure SQL MI, which is similar to SQL Server Agent that you can use to orchestrate package execution in ADF. In terms of pricing, we introduced the pay per hour, so we charge by the hour. You have to make sure that it's just like any dedicated Azure VMs. If you keep the VM running, we will charge it even if you don't run the packages. So we will actually make sure that you can actually manage the cost of your running your SSIS. We introduce pattern to just-in-time provision and restart and stop your SSIS. And we also introduce the Azure Hybrid Benefit or AHB option, where you can leverage your existing SQL Server licenses on premises in the cloud. When you do that, essentially you don't pay for the IP or intellectual property of SQL anymore. You simply pay for the VM costs and the managed service costs. Okay. Next, once you have your SSIS in ADF, you can still connect to your data store on premises. There are two ways to do it. One is through a VNet injection. So you can actually join your SSIS into a VNet connected to your on-prem network. And if that is not the solution you want, you can actually use a gateway or what we call a self-hosted IR that can be used as a proxy for SSIS. Another thing is the benefit for running SSIS in ADF. For example, you can still continue using Windows authentication feature. We introduced that into the infrastructure. You can integrate with Azure Key Vault, so you don't have to store the credential, your secret keys or access credential in the package anymore. You can actually fetch it from AKV. And if we don't want to use a credential at all, we actually integrate with Azure Active Directory or AAD authentication with the managed identity of ADF as a trusted service. So you don't have to use credential at all, and you can connect to, for example, Azure Key Vault, Azure Storage, or SQL DB or SQL MI without credential. And then, like I mentioned before, you can orchestrate first-class SSIS activities in ADF pipelines, chain and group them with other complementary native activities. We also introduce Azure Monitor integration, so you can view metrics of the SSIS operation or SSIS package execution. You can query logs. You can create near real-time alerts. And one thing that's really cool is we also recently announced a public preview of a data lineage. So you can actually have metadata storage using Azure Data Catalog, and you can see the lineage of your data integration when you run ETL on SSIS. It's been SSIS has been GA since June 2018, and is now running with 24/7 live support. Okay. Any questions so far on all the features to unblock and accelerate the migration, cloud only features, etc.? No. All right, let's move on.
I think no.
Okay, let's move on. So let's dig deeper on how we actually ensure security or a secure data access from SSIS PaaS in the cloud.
Sorry, Sandy, we have one also from Alexander. Does SSIS AR support custom SSIS tasks?
Yes, of course. Like I mentioned before, you can build custom components with the SDK that we have, right? And then once you do that, you just essentially install it on SSIS IR using a custom setup interface. Actually, the next section after secure data access, I will talk about custom setup and how to run a custom component on SSIS IR. Okay, is that all right?
Yeah, I think it's great, and that's it for now.
Yeah, I will show you how to do it, how to run custom components or third-party components on SSIS. Let's focus first on the secure data access from SSIS platform as a service, right? So let me reiterate. Like normally, when you run SSIS on premises, you can make sure that the data access is secure by placing SSIS engine and data stores in the same location behind a corporate firewall, right? But once you have your SSIS or ETL engine in the cloud, there are many ways to make sure that when you access data, it's still secure. One way of doing that is through the virtual network injection, like I mentioned before. So if your data store is actually isolated within a virtual network or configured with a virtual network firewalls, you need to make sure that SSIS-IR is also joining the same virtual network or VNet, so it can access the data. Another way to do it is, for example, if you want to leave your data stores behind corporate firewall on premises, and you don't want to use virtual network because it's the configuration of virtual network might be too complicated, or it might have certain network policy that does not meet your corporate rules. You can actually use a self-hosted IR or gateway as a proxy for SSIS IR. And this actually makes it simpler because you install the gateway behind the corporate firewall. Like I mentioned before, you can also use AKV integration to make sure that all your access credential is securely stored in the key vault. And like I mentioned before, also you can use AAD authentication with managed identity of ADF. That way, you essentially you avoid using credential altogether. Another thing that we introduced is you can also bring your own static public IP addresses or BYOP of SSIS-IR. So if your data store has firewall rules that only allow a certain IP address, you can actually add the static IP address of SSIS-IR, whitelisted it, or allow it on that firewall. Okay. Let's differentiate two methods to access on-prem data, like I mentioned before. The first method is actually joining SSIS-IR to a VNet connected to your on-prem network, and the other one is using self-hosted IR as a proxy for SSIS-IR. You can see on this picture, if you use the method of self-hosted IR as a proxy, essentially, for example, if you use data flow tasks, that data flow task will be broken down into two staging tasks, an on-prem staging task and a cloud staging task. So the on-prem staging task will move data from your on-premise data store into a staging area in Azure Blob Container, and then the cloud staging task will take over and move the data from the staging area into your cloud destination or cloud data store. Okay. While with VNet injection, there's no staging at all. Everything's done directly. So essentially, SSIS will reach down to the on-premises through, for example, express route or a VPN gateway to reach your data store and access data directly. Let's dig deeper on the pros and cons, basically advantage and disadvantage of using VNet. Okay. With VNet, essentially, we don't have any other new infrastructure. It's essentially all managed infrastructure. It's a PaaS, right? So that's one of the positive for using VNet injection, and it support all connectors. So every single SSIS connector, when you inject it into a VNet, can reach down and access data on premises. And like I mentioned before, but the positive of VNet injection is there's no staging. So there's a minimal latency, and SSIS-IR can access data stores directly. The disadvantages can be, for example, dependent on SSIS-IR regional availability. For example, if you are located in some region that we don't have SSIS-IR deployed yet, that means SSIS-IR cannot join a VNet in that region. So that is a limitation. And another thing is like the configuration for VNet is a bit complex. You have to consider many requirements. For example, there's a different permission or roles that the SSIS-IR has to have in order to access different data stores. For example, you have to worry about like how to configure a DNS if you're using a FQDN, for example, in your data store, etc. And one thing that might also be a disadvantage is like there are some corporation that has a very strict policy not allowing inbound traffic or public IP inside their VNet. For now, this is actually a blocker because for SSIS IR to be injected into your VNet, we need to have a way to reach down and manage those nodes, those compute resources inside your VNet. That requires us to have a public IP inside your VNet. Some corporation is okay with that. Some corporation has a strict policy not to allow that. We are actually working on a new VNet injection method that will be previewed next year. Well, where we will actually remove this, requirement. So the next VNet injection method will actually allow you to inject a SSIS IR into a VNet without public IP. Okay. The other thing is, for example, there are some companies that does not want, for example, to have express route or SMB. I think SMB is a protocol for file system that they don't want to have a direct connection from the cloud to on-prem data store, because SMB has a limited encryption, for example. And that way you have to you can actually fix that using a different method. Instead of a VNet injection, you can use a self-hosted IR. I'll explain later in the next slide. Okay. Once you join your SSIR into a VNet, you can actually allow inspection of all outbound traffic by installing a network virtual appliance or NVA or Azure Firewall or on-prem firewall. So that way you can actually audit all the traffic coming and going from your Azure SSIS IR. When you do that, you have to make sure that there are some rules that you have to follow. You have to make sure that some traffic has to be excluded from this forced tunneling from inspection, especially traffic between Azure Batch Management and SSIS IR, because these are the traffic that are required right now for managing the compute resource inside your VNet. So in order to do that, you can actually introduce a UDR or user-defined route inside your VNet. And also make sure that like some of the outbound traffic required for SSIS IR to connect to ADF or Azure storage is open on your firewalls. Okay. No questions so far on the VNet injection and forced tunneling for SSIS IR?
No.
No?
For now,
okay.
It's empty.
All right. So the next method to access data on premises is basically by configuring a gateway or self-hosted IR as a proxy for SSIS IR. When you do this, you can see there's no inbound traffic because self-hosted IR will be installed behind your corporate firewall. In fact, that gateway is actually the one that will reach out and connect to ADF. So there's no need for inbound traffic to manage those gateway from external from your network. The positive for that is like a very simple installation, and in order to enable self-hosted IR as a proxy, there's only a single property in the connection manager. It's called connect by proxy. So if you enable this property, it will automatically, the backend service will automatically split, like I mentioned before, a data flow task will be automatically split into 2 staging tasks when you enable this connect by proxy property. So it's very simple to set up. And you can use for staging, you can use an existing ADF Azure Blob Storage Link service. So you don't actually have to create a new one, for example. And like I mentioned before, it requires less exemption. And one thing that I highlight also, because on-premise to cloud data transfer is using HTTPS. So HTTPS, when you connect to like a file system on-prem, it doesn't use SMB anymore, because the SMB is actually happen only in the on-prem site. But when you go from the on-prem to data staging, it uses HTTPS, which is more secure and has a higher bit encryption than SMB protocol, like I mentioned before. Okay. The disadvantage of using self-hosted IR is essentially it is your own machine. So it's not managed by us, so you have to manage it yourself. For now, it also has a limited connectivity. It doesn't support all components. Right now, it only supports a standard data flow component. So all standard data flow component are supported. Some data flow component like enterprise one is not supported yet. We are planning for that for next year. And additionally, it uses a staging. So it's actually it has a two-step data movement when you move data from on-premises to the cloud. Okay. So you have to consider the pros and cons between those two methods, VNet injection or self-hosted IR when you want to access data on premises. Any questions so far, Jared? No?
No.
All right. So this is the time that I will go through the section that there was a question from Alexander before about how to run a custom component, right? So let's talk about the extensibility feature of SSIS IR in ADF. First, let me introduce you that SSIS IR also have two flavors, like SSIS on premises, right? You can have a standard edition or enterprise edition. The enterprise edition has advanced and premium features like CDC components, change data capture, and then you have also Oracle, Teradata, SAP BW connectors. You have AAS or SSAS connectors and transformation, and you have all these different complex transformation like fuzzy grouping, term extraction, etc. The Oracle, Teradata, and SAP BW connectors is actually those connectors actually it requires also the installation of drivers, additional drivers, and that driver is actually can be installed using an interface which is called the custom setup interface. So this custom setup interface is the one that you will use to install additional driver, API, assemblies, etc., and also like a custom component, for example. And you can use also this custom setup interface to alter the operating environment of your SSIS IR. For example, to start additional Windows services, to add Windows environment variable, to, for example, to run Azure PowerShell, to persist access credential, etc., etc. So basically customizing your SSIS IR. The way you do it is like you prepare an entry point script, what we call this a main.cmd file, and then all the associated files like the drivers, the API, the MSI, and you have to upload the main.cmd custom setup script and all these associated files into a blob container in your Azure storage account. And then you have to create a sufficiently long life SAS URI, the short access signature uniform resource identifier, that has a read and write permission to add in when you provision your SSIS IR. So that way, when your SSIS IR is started and the nodes are provisioned, we will actually reach out through the SAS URI to download all your files, the main.cmd and associated files, and run them and install them on each node of your SSIS IR. And when it's finished, we'll upload the execution logs into a folder also in your container, which is called main.cmd.log. And that's essentially the system how you can customize. It's very flexible. You can customize your SSIR to do anything you want, essentially. And recently, we also noticed that like there's a lot of custom setup which is actually common. So for this one, we actually make the UI more friendly, such that we remove the requirement for a custom setup script and the blob container. For certain custom setup, we can make the installation without script, and we call it express custom setup. I'll show you some of those express custom setup later. Okay, and with this interface, you can essentially support the installation of the free unlicensed component and also the paid or licensed components. Let me introduce the third-party licensing method that we introduced with the SSIS IR. As you know, the compute that running in the cloud, they are essentially volatile. Those nodes are not permanent, so it will always be allocated and deallocated depending on the operation that the customer does. Or, for example, when we actually release a new security patches or new features, right? So when customers start and stop their SSIS IR, scale it up and down, or scale it in and out, we essentially release the nodes and then we allocate a new one. So when you do that, you don't have this permanent machine signature like a MAC address or CPU ID. So the way a traditional way to bind a license to a machine like most components do on premises is not viable anymore. So in this case, we have to introduce a new invariant persistent variable that come with SSIS IR. And we introduced two types, which is a Windows environment variable and a SSIS system variables that can be used to bind a license and validate license. We call it the SSIS IR cluster ID and a cluster node count. And the way you use it, a typical implementation is like this. If you see the small guy on the left-hand side, that's like a customer, right? So you buy, for example, Sentry One or Kingspace of component, and then you get a license key and with your product. So you will implement a setup script that will install the license, the component and the license key, right? And when the custom setup script is running on SSIS IR, it will actually reach out to connect to the ISV activation server, like a Kingspace Soft or CoZero, etc. It will connect to the activation server and download or get the activation key. And then the custom setup that's running on your SSIS IR will store the activation key on a local registry or local storage. That process is called binding the license to your SSIS IR. And then when you run your package, if your package has this license component, the component itself will actually get a cluster ID from the SSIS runtime system variables, and then you compare that cluster ID and try to validate it against the local store or registry where you store the activation key. And that process is called the license validation. So license binding and license validation can be done using this cluster ID and cluster node count, for example. Any questions so far on this custom setup typical implementation?
No questions now.
All right. So we can go through the list of most ISV partners who have adapted their components, like I mentioned before. Most of the major one has adopted already. The interesting one that I mentioned before is, for example, Theobald Software. They are like it's like an expert in SAP connectivities, right? They have recently not only adapted their component to be express to be installed as an express custom setup without script. They also integrate with self-hosted IR, so you can actually use self-hosted IR as a proxy running Theobald Software component connecting to a SAP system on premises, and running both the package and the component both on the self-hosted IR and SSIS IR. So it's very advanced implementation. There's a blog on our site that actually link to their blog, for example. All right. So we're gonna go to the final chapter, which is the SSIS migration playbook. So far, no question on the custom setup. Alexander, yeah, is that clear enough for you? Yes?
Yes, everything's clear.
Okay, good. Let's go through the SSIS migration playbook. So the migration process usually starts with a DBA, the database administrator, right? The DBA can use multiple tools to access existing SSIS packages. You can use database or data migration assistant or DMA, or even SSDT. We have enabled SSDT to be able to do cloud compatibility assessment of SSIS package, right? When you do that, you'll produce an assessment report. The assessment report essentially highlighting potential issues on your existing SSIS package that need to be fixed or need to be overridden the values in the cloud to make sure that it can run in the cloud, right? So usually the DBA will pass that assessment report to a BI developer who has the ability to mitigate those issues. So the BI developer will look at the report and go through all different part of the package to make sure that If it's need to be edited, most likely 99% of the case, you don't need to edit the package at all. You just need to make sure that like what parameter need to be assigned what value, or what properties need to be overridden with property override to make sure that it runs in the cloud. So there's this a cycle of edit, test, assess, edit, test, assess by BI developer to make sure that all the packages can run. Once you're sure that all the packages can has the correct values to run in the cloud at runtime, then you do a batch migration or redeployment. There are several tools that you can use to do this. You can use database migration service or DMS. You can use the standard IS deployment wizard that can be launched on SSDT or SSMS. You can use command prompt utility like dtutil, and you can even do manual copy. You can essentially, literally copy your packages from the project folder on your laptop into Azure Files or a file system that can be fetched by SSIS to run in the cloud. Okay. So that's the process of migration. And let's go through the SSIS migration playbook. The playbook is essentially a 4x5 matrix that shows the recommended tool and action to do when you migrate your SQL Server to the cloud based on the package storage and the destination of the SQL migration. And you can see there are four rows, right? So there are 4 different storage type where you can store your packages. Like I mentioned before, for example, SSIS catalog, SSIS DB. You can store your package in file system. You can store the file your packages in MSDB or in a legacy SSIS package store. And then when you migrate your SQL Server, you can have a destination Azure SQL MI, where you can use the MI agent as the orchestration tool, or you can migrate your SQL Server to Azure SQL DB, where you can use ADF as the orchestration tool. So in this case, let me take one example. If you have your packages stored in SSIS DB in SQL Server, you can use DMS to do a batch migration from SSDB in SQL Server to SSIS DB in MI, right? Another thing, like for example, if you have your packages stored in MSDB, for example, DMS does not do the migration from MSDB to MSDB yet, but you can actually redeploy to MSDB in Azure SQL Managed Instance using dtutil. So dtutil can be used to essentially move all the packages from MSDB in SQL Server to MSDB in Managed Instance, for example. So all this action has been prescribed for you. So there is no blockage to migrate SSIS packages from different package store to different destination in the cloud. Okay. Any question on that?
No questions.
All right. So that we can do a demo. Let me go to my Azure Hub. How much time do we have? 3 minutes?
No. We have 13 minutes.
13 minutes for the demo, yeah? Okay.
Yeah.
Let me show you
now 12.
12 minutes. Okay. So this is my ADF portal. Let me see. How do I do this? So this is the ADF portal that you can launch from your Azure Hub, right? On the ADF portal homepage, there's an icon or an option where you want to configure your SSIS Integration Runtime. This is the first entry point where you want to provision your SSIS IR compute to basically to provision a compute engine to execute your SSIS packages. When you click on that, let's see. What's going on here? Oh, there you go. So it's open slowly. Okay, so it opened integration runtime setup pane. The setup pane, the blades has 3 pages. There is the general settings page, there's a deployment settings page, and advanced settings page. So on the general setting page, this is where you set up the compute property for your SSIS IR. For example, you give the name for your SSIS IR, right? You give the description. The type of the SSIS IR will be locked to Azure SSIS. and you can select the location of your SSIS IR. We have more than, I think, more than 20 recently. We have recently the new one, for example, we released in Germany, Japan, UK, Canada, East, South Africa, North, etc., etc. So one thing that you need to remember, if you use SSIS DB to store your packages, make sure that you provision your SSIS IR in the same location with your SSIS DB. Because when you run your packages on SSIS IR, the SSIS IR will try to write execution log to SSIS DB, right? So if your SSIS DB is in East US and then your SSIS IR in West Europe, there will be like a cross-regional latency. So make sure whenever possible to have the same region for your SSIS DB catalog and your Azure SSIS IR. And then you can select the node size. This is, there are two dimensions in terms of the number of CPU cores and the size of the memory. You can see, you can select the size of the node for SSIS IR from 1 core. I think there's 1 core somewhere. Yeah, there's a 1 core all the way to 64 core. And the memory it goes from the very small one, like a 3.5 gigabyte, to like a more than 452 gigabyte. So depending on whether your packages are compute intensive or memory intensive, you can choose the right size of the node. And then once you choose the node, then you decide how many nodes you want to have in the cluster. We offer you all the way from 1 node per cluster to all the way to 10 nodes per cluster. You can see when you do this, the prices keep increasing. If you have 10 nodes with 8 cores per node, right, it's going to cost you $20 per hour almost. So if you want to keep it like cost effective, maybe just 1 or 2 nodes, for example, right? And then you can choose the flavor of the SSIS IR if you want to have standard edition or enterprise edition. Like I mentioned before, enterprise edition have all these premium advanced features like CDC, change data capture, Oracle, Teradata connector, etc. And the price is different also. If you select enterprise, you can see the price change, right? See. And then if you want to save money, if you are actually already have SSIS or SQL Server running on premises and you want to retire them and running in the cloud, you don't have to pay for the IP or for the license anymore. If you have software assurance, SQL Server license with software assurance, you can actually bring your own license to the cloud. And then when you do that, you get a significant savings in your running costs, because then you don't have to pay for the license anymore. You're just paying for the size of the VM and the managed service, basically the PaaS service that we offer. Okay. Any question on the compute property or the general settings of SSIS IR?
No questions.
Okay, let's move to the deployment settings. In here, you have 2 checkboxes, essentially to allow you to have any deployment model, right? Like I mentioned before, it supports both the relatively recent project deployment model, where you can create SSIS DB hosted by a SQL database or managed instance on your behalf, or you can store your packages in the file system, Azure Files, or MSDB, right? When you select to create SSIS DB, then you have to bring your own SQL DB server or managed instance. You can select the Azure subscription under which your SQL DB server is provisioned, right? And then you can select the location and make sure you can see that the location is the same as my SSIS IR, to make sure that there's no cross-regional latency between SSIS IR and SSIS DB. And then you select the SQL DB server or managed instance available under that subscription in that region. After you do that, you can decide whether you want to use AAD authentication with managed identity for Data Factory. That means you don't have to use server admin credential for us to manage the SSIS DB on your behalf. You can see that if I check this checkbox, you don't have to enter the credential anymore, because then you have to provide your ADF managed identity. You have to create a contained database user of your ADF managed identity so it can access your SQL DB or a managed instance. And if you want to use the traditional server admin credential, you can do that also. You can enter the username and password in there. And then if you use SQL DB, you can select the service tier of the SQL DB, which is the size of the SSIS DB hosted by the SQL DB server. We offer all kind of sizes, starting from the basic one, basic standalone databases, general purpose, business critical, hyperscale, all the way to Elastic Pool. So you can actually even use Elastic Pool to host your SSIS DB, for example. Okay. By default, it's also selected the S1. You can change that. And if you don't want to use SSIS DB, for example, you want to host your packages in file system or Azure Files, you can select to create a package store. A package store is essentially a UI package management layer that you can use, you can access on SSMS. Just like the legacy SSIS package store, the SSIS IR package store is the same way. So you can basically put this management layer on top of MSDB or file system or Azure Files. In order to create that, you can click on new, for example, and you can give your package store name and select the link service to your your package store. You can use the link service to the storage where you host your packages, either in Azure Storage or like Azure Files, or in SQL MI where it's where your package is stored in MSDB, for example. If you don't have existing ADF link service, you can create a new one. And by default, you have to make sure that it uses basic authentication, because like SSIS IR package store only
Excuse me,
support basic
Sandy.
Okay, go ahead.
We have one big question.
Okay, go back.
Maybe
go ahead.
It will be easier if you just read it.
Oh, okay. Let me go.
You know where in
this
Zoom,
one?
in Zoom application, you have Q&A section.
This one, right? I am working in a company which has over 150.
Yes, exactly.
Okay. Okay, let me read this. I'm working in a company which has over 150 SSIS packages on premises. Perfect. That's exactly the type of scenarios that SSIS IR in ADF address. Okay, that our warehouse database for it to provide, and then take couple of our evidence. Is there any way to estimate the cost? Yes. Well, our recommendation is basically you want to have the same size of your SQL Server running your SSIS in the cloud. So if your SQL Server currently running your 150 SSIS packages using 8 core, for example, then you probably want to provision also 8 core SSIS IR in the cloud, right? The prices is based on the length of the you leave the SSIS IR running. So if your SSIS running for like 1 hour, then it will be charged 1 hour, the price for 1 hour of leaving the SSIS IR running. But you can actually reduce that by using a just-in-time pattern. I will show you later that you can actually start and stop your SSIS IR just in time before and after you execute your package. So if there's no package running, you make sure that the SSIS IR is stopped. And when there's after your package is finished running, you make sure that you also stop your SSIS IR. So just in time start and stop, basically. The way to estimate the cost is, well, you can actually try it, you can test it. Essentially, the same core, if it's the same core of machine, then the amount of time that running the same type of package is almost the same. So there shouldn't be too much different running the same size of package on 8-core machine on-prem compared to the 8-core machine in the cloud. Okay, does that answer your question? The best thing to do is like there's also a link to let me show you a link to our documentation. Give me a second. Let me see if I can do this. There's a documentation here. Yeah, configure high performance SSIS IR. Let me open this. So this documentation will show you how to size your SSIS IR to run different packages. All right, and you can see that way that you know how much time you need to run your packages depending on the size of your SSIS and number of your SSIS number. And there's also a variable that you can set, for example, the maximum parallel execution per node. If you have like a lightweight packages that you can run in parallel in a single node, you can do that also. So let me pass this documentation into the. How do I do this? I can just. How do I do this? Type answer. Yeah. Okay. If you can see that I type a link here. I hope it works. Where's the answer? Yeah. So you can see there's a link there. You can look at the documentation how to size optimally your SSIS IR to minimize the cost of running it. Okay. All right. Let's go back. Is that okay, Jarek? Can I go back to the presentation?
Yes, of course.
Okay. Let me see. Where's the? Okay, so I was talking about how to provision the package store. I'll just show you, and then let's cancel this. And if you don't want to create SSIS DB or even create package store, you just want to, like I said before, literally just copy the package from your file system or from your project folder to Azure Files. You can do that too. In fact, it's just like the simplest deployment settings because you don't need to create SSIS DB nor package store. Okay, you can do that. And then now finally the last, let me move this thing up at the top. The last blade is actually the advanced settings. This is where you can decide on the concurrency level of your node. You can run, for example, 8 package in a single node, or even double that, 16 package in a single node. That means like because my node has 8 cores, that means one core can run 2 packages, for example. So you can play around with the parallelization of your node. And then if you want to customize your SSIS IR, this is where I mentioned before. You can enter the custom setup SAS URI, where you store your custom setup script and your custom setup files, right? So we can download it and install it. Or you can use Express Custom Setup. This is the one that I want to highlight for you. There are some custom setup that you don't need the container nor script to install. Here, for example, you can run cmd command. You can see. You can just cmd command is a way to process your access credential to your file share. For example, you can put your targeted computer, your account username, password, etc. there. Or you can add environment variable. You can introduce environment variable in your SSIS IR, so you can use it inside your package. So you can execute. You can run with using environment variable, for example. And you can install license component. In here, you can select the component that has been integrated with SSIS IR. So most of our partners already has a custom express custom setup. For example, there's a SentryOne Task Factory. There's OH22, HEDA.io, SQL Phonetics. This is the one that I mentioned before as an alternative to data quality services. There's Kingswaysoft. Kingswaysoft has 2 types of custom third-party component you can install. You have Theobald software, Acorsoft, and CData. Okay, so if you select one, all you need to do is just like enter your license key, and that's it. There's no need for a script. There's no need for container. Once you enter your license key that you purchase from them, your SSIS IR will have a SentryOne Task Factory embedded in it. Okay. So that's really cool, I think. Another thing is like another way to use Express Custom Setup is to install Azure PowerShell. And here also, you don't have to add any script. When you do this, you just select the version of your Azure PowerShell. If you look at here in the link, I think you can find out all the version that we support. Where is it? I just check. Yeah, you can see all this version. So you just type 4.2.0 or 5.00, 5.1.0. When you type that version in here, you just type like 5.0.0, then that version will be installed on your SSIS IR, such that you can run execute process tasks, for example. Execute process tasks can have a PowerShell script to run on those Azure PowerShell. Okay. Let's go back again. That is custom setup. Next is if you decide you want to join your SSIS to a VNet because you want to access data on premises, for example. Let me move this thing up. All right. In order to do that, you select the subscription under which your VNet is provisioned. The location of the VNet is, like I said before, it's the same with the location of your SSIS IR. So that's the limitation of VNet injection. It only supports the region where we have a SSIS IR is deployed, right? And it's always ARM VNet. We don't support classic VNet anymore. We just simply enter the VNet name and subnet name. And when you do that, we will inject your SSIS IR inside that VNet. So any data stores inside that VNet can be accessible. And if that VNet connected to on-prem network, then your SSIS IR also can access on-prem data stores. Another option once you create the VNet is you can bring your static public IP. In here, you have to introduce two static public IP address. The reason why you need to provide two static public IP addresses is one is used for a rollout. So when you run your workload, so it will use one public IP address. While when we release new feature, etc., we actually have we use the other IP address to release a new version of SSIS IR. And when your workload is finished in the older IR, we will hot swap the IR such that you always need to whitelist both the IP address on your firewall, for example. Okay, so you provide the first static public IP address and second static public IP address there. If you don't have one, you can create a new one. And then finally, the other advanced settings option is to set up a self-hosted IR or gateways as a proxy. In this case, you can select the previously provisioned self-hosted IR. You can install it on your local machine. In this case, I installed one in my laptop and one in my desktop. Right? You can select it, and then you can select the staging storage link service. This is where you move the data into the staging area such that SSIS IR can pick it up. And then you can name the staging path, or by default, it use a container. By default, it just use a default container, sorry. All right, so those are the advanced settings. And when you finish with those properties, you have the summary, and it will tell you all the property that you set up for SSIS IR, including the general compute, advanced, and deployment setting. It'll highlight the price that you will pay, estimate of the price per hour. And there's a link to the latest prices, and then you can learn how to deploy the packages once your SSIS IR is running. And then there's also, like I mentioned before, there's a path, there's a documentation. I'll just open it here. There's the documentation to show you a pattern to start and stop your SSIR just in time. So that way you can manage the running costs, for example. Let me just show you the documentation quickly.
Excuse me, Sandy, but we have already out of time. So
okay, that's almost finished then. Like, let me just click on this and it's finished. Perfect timing. And when you do click create, you essentially create the SSIS IR, and that's it. And then it will take you to the manage hub of ADF portal. It takes a bit. It takes slowly, I think. Let me see. Normally, it should just take you right away. Let me see if it's here. What happened? Yeah, there you go. Sorry. It's a bit slow, my laptop. And here you can see the new one that I just started. It's actually starting. If there is no custom setup, it will be started and ready to run packages in under 5 minutes. If you join it into a VNet, it takes about 40 minutes right now. But next semester, when we have the new VNet injection method, it should also be as quick as under 5 minutes. Okay, that's it, I think. Any other question so far? Oh, before that, before I go, let me just show you. Let me show you the resources that I have in this in the deck. This is my email. In case there are some questions that I didn't have time to answer, you can always email me. This is the SSIS team block where you can. Let me just see. The theme block where you can visit, we publish pretty frequent all the new features we have on SSIS IR. And then there's all the lists on the documentation that I mentioned before. And that's it. Thank you.